In this video, I will explain you the relation between focal length and radius of curvature. Now, focal length is the distance measured from pole till focus. This is the focal length f. Now, the distance measured from pole to center of curvature is the radius of the curvature. So this is the focal length and this is the radius of curvature. Now we need a relation between R and F. Let's say an incident ray, this is the object. Okay, now from the object an incident ray is coming in this direction, and after meeting the mirror it will make an angle of incident with respect to the normal. So always in a circle, the normal to any surface would pass through the center of the circle. We know that property, right? So the normal at any point would be nothing but the radius that formed when connecting that point with the center of curvature. So always at this point also, the normal at this point would be simply the radius, and that should pass through this point and the center of curvature. Okay, would be in this way. Okay, at all the point the normal should be simply the radius that is passing through that point. So this is angle of incident, we don't know this. Okay, so angle of incident would be equal to angle of reflection as well, so both should be the same angle I. So if this is I and I, the whole thing would be 2I. We know that in this case principal axis is parallel to the incident ray. So if these two are parallel lines and these two are alternate angle, so alternate angle should be equal. So if this angle is I plus I 2I, the total is 2I, this should also be 2I. Okay. Now, we have two triangles formed here, and one more thing. If this angle is I, this angle also would be I, because those two are alternate angle. See, these two are parallel lines and these are the line passing through the parallel lines. So if this is an angle I, this should be its alternate angle and that should also be I. So this is I and this is 2I. Now I am just connecting a line here, and this is, say for example, the object height h itself, h, because these two are parallel lines, right? So the distance in between two parallel lines would always be equal. Now here I am going to take from triangle, so this is C and this is pole. So pole and these 2 points are the same, so I am going to consider the same point itself, P, and let's say this is my point A. Now in triangle CAP, tan I is equal to, what is tan I? Opposite divided by adjacent. So AP divided by adjacent is CP. Now similarly in triangle FAP, tan 2I is equal to opposite AP divided by adjacent FP. Now AP is simply H, or you can keep it as AP itself. Okay. Now for small angle I, sin I is equal to tan I is equal to I. This we have learned, right? So tan I would be equal to I. For small angle, tan 2I would be equal to 2I. So I is equal to this and 2I is equal to this. So I will multiply 1 with 2. So this would become 2I. So on multiplying 1 with 2, I will get an equation 2P by CP is equal to 2I. Okay, now for 2I I have one more equation. What is that? AP divided by FP. So this is 2AP, right? 2AP. Now 1AP and 1AP would cancel. Okay, so this implies that cross multiply 2fp is equal to cp. 2fp is equal to cp. What is fp? fp is the focal length. So 2 into f is equal to, what is cp? cp is the radius of curvature. So r is equal to 2f. This is what the whole derivation says. This is very, very important. Always r would be equal to 2f. Okay, thank you.